Good afternoon, Nerd Fam, and welcome back to St. Louis, Missouri. We're here midway through day one of our 3 days of coverage here on theCUBE. My name's Savannah Peterson, really pumped to be bringing you a super special segment next with Dave Vellante. Dave, what's your favorite bird?
I think the owl might be my totem.
Is it?
Might be. It's either that or the cardinal.
I love it.
I haven't quite figured out yet.
Those are very
some
different
time, but
birds.
it's ticking.
Yeah, well, I mean, I'm obviously into birds. There's a bird on my forearm. My mother's a birder. I'm all about the birds. And our next guests are going to tell us about how they are saving one of those breeds. Please welcome Josh and Chris. Thank you guys for being here.
Thank you for having us.
Guys.
It is not every day in enterprise techland that I get to talk about spotted owls. So I got to say thank you for that.
Well, I'm always excited about spotted owls.
So we just got to dive right into that, and then we'll break down the tech that's powering this. But tell us about the project. Tell us how you're saving them.
So I work with the United States Forest Service to monitor spotted owl, which is an endangered species, to help us what we consider maintain habitat. So some owls, like the barred owl, actually have crossed states and come into our habitat, and they're taking away the resources. And that, coupled with the lumber industry who farms trees in Oregon, they actually want to be able to take down trees without affecting habitat as well. And so our goal was, we've been working on this since 1996, okay? And our goal is to really enable the lumber industry to do things in a positive way and to feel good. No one wants to.
That's not something that most people associate with logging. For example. It's not always the most sensitive group of people in terms of the public perception.
Correct.
So I think that's actually quite lovely to hear.
When we talk to them, no one wants to take down and hurt animals, and everybody wants to maintain the forest. And we've even run simulations, which we'll talk about using the tech, that shows that hyperdiversity in forest is needed to actually maintain species. So if I don't have the animals, we can't disperse the seeds properly, and you actually go to monodominance with the trees, and you'll see that where you have just a pine tree forest. And when you actually go down to like the Amazon, you have a tremendous amount of diversity, and that's because of hyperdiversity maintaining all the species. And so this is an important aspect, and as we lose keystone species, the forest will collapse. And if that happens, we will not have the same planet that we lived in.
Oh my gosh, I mean, that's the truth. I'm curious, so obviously endangered, how did you choose the spotted owl for this particular project?
It actually landed on the endangered species list. And so the United States Forest Service was asked to start monitoring the habitat for that. And so the Pacific Northwest is the main habitat. And so we actually installed, we right now have about 5,000 autonomous recording units between San Francisco and Canada that are actively sampling the sound. And what I did is I wrote an algorithm where we can find all the animals in the forest using sound. And so I can just record the forest, and I can tell you what the species are. I can tell you when a tree falls in the forest and no one was there.
Does it make a sound?
Yeah, no, it does. It really does. I can tell you
mystery
when planes
solved,
go
y'all,
over.
mystery solved.
Right. And so we actually got that up to about 130 species right now.
Wow.
And and so we try and couple that with camera trap data as well. And we can actually then get down to even male and female with the sound. I can do Doppler shift and tell you which direction they're heading. We can even get down to the individual bird sometimes and track that individual bird.
Wow.
So Josh, the edge has gone from this sort of data rich but information and insight poor environment, and now you're bringing AI to the edge. How should we be rethinking about AI at the edge?
Well, there's a whole kind of shift, if you will. So we were in the previous and everything's so compressed time-wise. So let's say in the previous 3 to 4 years, because that's when we sort of had this big bang moment with ChatGPT and so forth. As we move past the training of the models, now we're getting to the deployment of the inference models. And that's, I think, what we really would focus on now. So there's still going to be a lot of training happening, but inference is going to really move into the fore. And that's a lot of what Chris is doing.
Yeah, I mean, in the end, we're leveraging different technologies for training that we are at inference, and by pushing inference out towards the edge, we reduce the impact of managing the data, and we also create a better temporal aspect to that data. If I can't get through the data quickly enough, it's meaningless for the forest and the lumber industry to actually make active decisions. And so we really need a more real-time or semi-real-time solution, which is why I need to push the compute out to the edge as far as possible.
And they're different workloads too, right? So when you ask a really complicated question to one of the AI bots about what should I do with my retirement? And it's thinking, that's not the kind of question that you're going to have a server at the edge answering. But for something like this, it's absolutely perfect, and those models are already trained. So there's a whole variety of different use cases, and this is one that works perfectly at the edge for inference.
How much of the data do you persist? How do you decide what to persist?
So let's talk about the data for a minute, because AI is a data problem. It's not a processing problem. The processing comes from data, okay? And so right now, between those autonomous recording units, we're collecting about 250 terabytes of data every month and a half. And I didn't need to process that. It turns into about a half a petabyte to a petabyte for one experiment. And we have to keep all the raw data. I have all the raw data going back to 1996. Okay, and that's because as I changed the models and I retrained the models on larger, beautiful machines that we've been getting, we were able to go back to the data and actually pull more information back out. Okay, as I increased the number of species.
I was wondering about that, because you've got quite the historic data.
We're trying to look at how things have changed over decades, not just small pictures of time. We do this not just in the forest, but also the ocean. I have the Ocean Observatory Initiative as part of our grant, and it's a $1 billion project where I have minute-level data coming from the ocean. And it's lasting for 25 years. And so we have to have a both local temporal aspect, but a large temporal aspect, so we can see changes over time, because they don't happen rapidly, they happen slowly and gradually, and we be able to react in such a way that we can change it back.
So you store it all?
I store it all.
And then
I have petabytes and petabytes and petabytes.
And that varies by use case, right?
Yeah.
I mean,
well, and one of the interesting things is the model that that Chris is talking about in terms of the workflow. That's a variety of different verticals. So it's interesting that continuous pre-training and training of models with new data, and then there's things like RAG, which allow you to get even more context. That model, for the way we're using AI, works in a variety of different scenarios. So it's really interesting to see. Chris has got a really interesting use case because it's saving the planet. It's awesome. But you can use that in a lot of different areas as well.
And that's what's great about the hardware, is that it's able to be used across different experiments, and I can move different experiments on and off the same piece of hardware. It's not like certain other types of lab equipment. We treat these like they're a piece of research equipment, and we treat them like research equipment. And in that sense, it's one of the greatest pieces of research equipment because it's unbiased.
Fungible.
Yeah. I can do anything with it.
Yeah.
It's what I decide and how creative I can be as a scientist.
So let's dig in there, because it's so cool that you have such a long history, both of working together as well as with this data set. I mean, what a true snapshot of an environment and now all these other species. So I'm very curious about the journey as to when new things have been unlocked along the way, and what you think might get unlocked as we continue to move forward.
So I just published another version of our network that we do, and we're very excited about that. And that's the point, is that what we're trying to do is really get down to individual birds and stuff like this, and be able to separate pieces out a little bit more. And so as we build and the data is being held, we have to get the processing to match that. The other piece about this is I'm spending a tremendous amount of labor to go collect the data. So right now, all of those devices have cards. And so we can't just put Starlink on all the devices, because the cost would go through the roof. And so I literally have to send people out to collect data right now. And that aspect of it is the actual part that limits us.
I bet.
the truck roll.
Yeah. And they're bringing me boxes of data, and I didn't have to transfer it around and do all of this. And that delays the rate at which I can do things. And so working with Supermicro, they were able to build us a workstation that put liquid-cooled GPUs onto a workstation. Putting GPUs out in the forest is not easy. They take a lot of power, and they consume and generate a lot of heat. And I don't have a data center out there.
Yeah, and you don't have a team monitoring that,
right,
in a treehouse somewhere to try and make that work. Yeah.
And so what we worked with Supermicro to learn was that we could train on Grace Hoppers and then push out to this workstation that had liquid cooling built into it. And so I didn't need to have a data center. I didn't need to have cooling. I could put it at a ranger station and then try and do a wireless mesh from those devices back. And that's how we should be working more. And so that way I can get semi-real-time or real-time data coming back, so that way I can always know what's going on. And that's where the data needs to reside. Our limit has always been either processing or disk space. I could either take processing out there, or I could take disk space out there, but I was never able to take both.
And now you can. And so we heard from Solidigm earlier that by next November, they're going to have a 256 terabyte
Yeah,
drive.
smaller than our freaking cell phone.
You guys are going to double, triple, quadruple the GPU power that you can fit into a system.
The shared memory footprint is making a real game-changing.
So explain what that does to the economics.
So go ahead.
This is me. Okay, so I have so much data. Okay, so we're taking the sound data and we're talking about petabytes of it. And so when I start to try and train a model on this, the GPUs that we had in place were not going to do the job. And then I have to start moving to super pods and connecting multiple GGXs together. And then along came this thing called a Grace Hopper. And the Grace Hopper allowed us to take advantage of unified memory. That means that the system memory, even though it may not have the same level of performance, it changed the scope of work that we could do with the data sets that we had.
At a much better cost point too. That's one of the critical things.
It's the cost point. It's the fact that I'm not putting out $250,000 to $500,000 to do the same work. I can get one of these machines for $30,000 to $60,000.
And the TDP and energy draw as well.
Because of the GPU costs are so much less expensive for an N-1?
It's because before we were taking multiple GPUs, which have each a cost to them, and trying to stitch them together to get memory. We're not doing that anymore. We take the system memory that I've already paid for on the box, and I'm leveraging that. This was done a long time ago with NVIDIA and IBM through a coherent accelerated processor interconnect called CAPI.
Yes,
and
right.
in the end, that was abandoned for what we have now. And so really, unified memory is the end all goal. And we've even seen that in certain cases, I've gone to my CUDA code where I run the simulations to understand hyperdiversity, and in one line, I could change one line of code and I took advantage of unified memory. How easy of a change is that to change your scope of work? And I went from landscape sizes that were like very small to the size of the Amazon rainforest.
But I just want to put a finer point on it, make sure I'm clear. But when the next generation GPU comes out, and it's cost effective enough, you'll want it or not necessarily? So
no, I do want it.
Okay, so what I'm trying to get to, because everybody's talking about the depreciation cycle, right? You saw the hyperscalers, they extended their depreciation cycle from 4 to now 6 years. People are saying the depreciation cycle on these GPUs should be 2 years, but here's my question. Will today's training GPUs become tomorrow's inference?
Yeah, so I actually just connect multiple Grace Hoppers together now.
And you can do both.
So I think that's a yes.
Yes.
Right?
It depends on the workload, right? So the reason we're getting these benefits of kind of the economies here is that where it used to be 8 GPUs, you can have now 1 GPU and 1 Grace Hopper processor with 576 gigs of shared memory, where you used to have 8 GPUs. And so that kind of shared memory economics, and although as he mentioned it's tiered, so it's not all apples for apples, it's definitely good enough to do these sorts of training drills. So there's definitely going to be an opportunity to use those GPUs and inference, I think.
And what about the power? So that's good news for the industry. All
this power's lower
all
too.
This bubble talk, and that was my next question. What does that do for the power envelope?
Right, so the power envelope for the large training data sets is going up, but there's also core efficiencies associated with that because of things like liquid cooling. And we've got the liquid cooling on the disk that Chris mentioned, but in addition to that, we've got everything from, you can do forced air cooling, you can do dry cooling, you can do sidecars, which are basically retrofitting an existing air-cooled data center with liquid. So there's lots of different opportunities, and it's all about the workload. There's a variety of different workloads, and they each have their specific sweet spot, and we can help to tailor that so you make the most of your dollar.
And that hybrid configuration, that's here to stay, or is that like a
definitely, I think, because so what we're seeing is for the most part, greenfield, which would be new data centers, are going to be fully liquid cooled. But because of the power requirements, a lot of folks need to stay with their existing air-cooled data centers, and that's where this hybridization really plays an important role. And as you get to the edge, that's even more the case. So, and then there's a whole nother discussion we can have about containerized data centers, where you've basically got the whole data center in a box.
You're shipping a pod.
Yeah, exactly. So there's lots of different options, and there's basically, if you work with someone like us that can give you that expertise, we can help to walk you through that whole decision.
Let's talk about the water cooling and the performance. We've all been buying these GPUs, and the air cooling them, you're actually giving up half the performance. We showed this with Supermicro and NVIDIA. They allowed us to publish some work that shows that these A100s that were older were actually faster than a modern Grace Hopper. And it's because the liquid cooling gives you back the performance you paid for, but we're losing. And so we can stick A100s out into the field that are literally faster than the H100s that you're buying today.
Okay, that's wild. And these are
This is great news.
And these
actually.
it is, and this is really outer edge. You know, this is. I mean, this is the edge
Far
of the
edge,
forest.
yeah.
Like this is, but like in a really lovely way. Josh, I got a question for you. When Chris came to you and was curious to go do this, first of all, how did you go about even determining what was going to be the best to survive in these environments for an extended period of time?
Fortunately, with somebody like Chris knows, as you probably have gathered, listening
Yes.
to, he has a very clear opinion on
That
what he wants to
design
do
brief was
and how he
pretty
wants
tight.
to
Yeah.
do it.
I
So
know
was
the
just-
technology, guys.
So I was just very happy to work with them on it. But I want to say, I'm an former abalone diver. I want to make this stuff, they've closed the abalone fishery in California. The kind of the utility of this in a lot of different areas is going to be huge. So I just want to help to kind of spread the
other
good
piece
news
is
of this.
I get a weekly call with Supermicro for the last, I don't know how many years, and I get to talk to an engineer. In Peru, she's an amazing engineer. She's the one who helped design the liquid-cooled GPU workstation. She had one under her desk. Talking with the engineer who designed the technology and having that level of access is not normal, but Supermicro rolls out the red carpet to me. And so they help me change the way we do science using technology.
Which is gorgeous. So you mentioned that this solution can work across a lot of different things, not just for the owls and not just for other animals in the forest. What are some of those other applications where it's best?
Particularly with the GH200 that Chris was talking about, we've just released a world-class benchmark in Stack, which is a financial benchmark. So that would be in the FSI space, financial space. And then in addition, there's something called Gurobi, which is, this is really interesting stuff. This is kind of manufacturing automation. So it allows you in regression. So in a nutshell, it's basically when do I turn on the power plant? When do I turn it off? When do I drill for oil? When do I stop drilling? Even where do I, if I'm building a new superstore, where should I put the displays based on past data? So there's lots of different areas where this makes sense, and that's just with the GH200. There's all the other.
So I think it's important to understand that people were reluctant at first to go towards the GH200 because they saw it as a separate architecture and thought the software stacks weren't going to be there, and that's not true. We've been playing in ARM for a long time. We've had the NVIDIA Jetsons, we've had a whole bunch of different ARM technologies, and all of them brought all that software forward. And so bringing these GH200s online was so easy. It was just, they rolled out, we had them up in 3 hours, people were using them, and so I think I want to remove that concept that moving your workloads towards the ARM processor is going to be difficult. That's not true. We found just tremendous return for moving to that, and it cost us nothing.
So how close are you now, I just want to circle back, how close are you now to real-time monitoring, and
So
what's the bottleneck? Is it compute, is it data, is it
the
location?
humans bringing the boxes
Is it,
down
right?
to
It
the office.
becomes the wireless mesh. I have students in the engineering department right now working on the wireless mesh using LoRaWAN and how we can increase, because as I increase the bandwidth, I increase the power, and getting power in the forest is difficult. Okay, I mean, solar panels, there's a canopy, I don't get much sun. And so that's what we're working on right now, and we're submitting more grants to get the money to buy those devices. So we have right now we have edge devices doing Starlink, but they're very few and far between because of the cost. And the Forest Service asked us to move to a different model. And so if we can get the LoRaWAN and the wireless mesh to work, which is our last piece, we should be off to the races by the next year.
Okay, so compute you got covered, the data you've got covered, it's really that
it's the
wireless
interconnect between the
capability.
two.
Yeah. It's the edge device
the forest
to
is the problem.
To the ranger station.
Yeah.
And
Yeah,
the
to the
fact
folks
is we're going to
looking
put
at the
these in
data.
ranger stations.
Yeah. So, okay, so this is a fun game. What other, so for the other environmentalists who might be listening, the scientists out there in the world right now who are watching this thinking, oh my goodness, we should monitor insert X species here.
Abalone.
Yeah,
Condor.
abalone, I love that. I've been to the abalone farm in Cayucas when it was still open,
Well,
when the fishery was still open.
Just pick the whales, for example.
Yeah.
Shipping cargo vessels off the coast will hit whales and kill them, and they don't want to do that. How do we leverage this edge AI to put buoys out there that tell them where the whales are? And so we don't lose them and stuff like this. We really need to implement.
So what would you tell that person who's thinking about that? How do they get started? How does the animal-loving scientist get started with somebody like Supermicro?
Well, actually, you contact Supermicro and say, give me an engineer, and that's what they do. They just
work
roll out engineers.
We will roll out the red carpet for you.
You
And the
really
other
do
thing-
make it sound easy, Chris.
It was, though. That's why I'm saying it. So that's why I have a 20-year relationship with them, because I can always go to them and I can count on them to basically put the engineer behind it and say, go talk to the engineer, here they are. And it doesn't matter how much time it takes, the engineer is always there and will continue the conversation and find the solution for me.
And the other thing is, a product of a public university, this kind of fundamental science that's being done at our public universities that we support with the government's absolutely critical. So let's keep doing that, and it's creating huge results like this that in the private sector people aren't really incentivized to do. So what Chris is doing is really, as you can probably imagine, you could go have a different job in the private sector. So we really need to support and validate what Chris and his
We need
folks
industry
are doing.
partners, especially right now as funding models are changing with the government. And we need to recognize that those changes affect your ability to get cool things to come out of science. I mean, the fact that GPS works and the fact that you have your phones and all these things that we have are driven from science first. And so we really need industry partners like Supermicro to help us get that message across and change the way we're doing stuff.
And we'll work with you to wring out the best possible value for your investment. And I'm personally, as you can tell, I'm excited about it because I support public universities and the work that he's doing.
Yeah.
I look at it like this. If I'm not here every year talking about how technology changed science, you guys failed. All of this room failed, okay? Because that's, in my opinion, what you're here to do.
Yeah.
And every year there should be something new for me to apply. And it should be exciting. That's the way it should be.
It should be. All right, last question for you. How has this positively or otherwise impacted the owl population? Is it working?
It is, and that's the benefit. That's why we've been doing it so long. And that's why we keep pushing out publications around this, is because it does work, and the forest industry counts on us to do that. We farm trees. We even put signs up what year this was planted, and they really count on us to communicate to them where those habitats are. We would like to be able to give them information on a daily basis, not monthly and stuff like this. Or
so hopefully
quarterly,
you can say that soon.
And he didn't
maybe
even
next
talk
year.
about the Dungeness crabs. You're saving
Yeah,
that too.
and
it's a great, because these are public-private partnerships that
I use
really
the
yield
same
fruit.
machine to go out and put onto ships and stuff like this as well. And so the crab industry's having us talk about putting them on their fishing boats, because we put sensors and cameras into the thing so they don't have to bring them up. Okay? They're even trying to get us to put buoys out there so they don't have to take the boat out. They can just wake up, check the crab pots, and go and do something else all day. And I'm behind that. I don't want them using fuel
I was just
to
gonna
go
say, it's
out
better
there.
for the
This is a brilliant idea. And that these types of devices are what I can put on a ship, because it has the liquid cooling. I have a generator with enough power. It plugs into a 515.
The architecture enables that.
It
Right,
does.
so if you want to change the world for good, work with Supermicro and Chris, and we'll work to make it happen.
That's what
You've
we do.
convinced us.
Good.
Very much convinced us. Josh and Chris, thank you so much.
Thank you.
This
Thanks, guys.
has been not only fascinating and educational, but also very heartwarming. Thanks
Yeah,
for
right. I'm
saving
going to share
the
it with
owls.
my kids. So
Yeah.
AI's got some good things that come out
Dad
of it as
did
well.
good at work today.
Right.
Yeah. we can confirm. Do you want to say hi to the kids? Go
Hi,
ahead.
guys.
Yeah, there you go.
Emily.
Right there, yeah.
Steve
Sweet.
and Emily, hi.
All right, gentlemen, thank you so much. And thank
All right.
you, Dave.
Thank you, Savannah. Thank you, Dave.
Yes.
Get it, guys.
Bye.
And
Good
thank
work.
all of you, wherever you might be or whatever tree you might be roosting in. We're here in St. Louis, Missouri. It's Supercomputing 2025. My name's Savannah Peterson. You're watching theCUBE, the leading source for enterprise tech news.